problems for problem set 82. Okay, let's do number 1, 2, 3, 4, 5. Let's do all the story problems. 6 and 7 is today's. 10. 12. 15. 16. 18. 21. 24. And then 25. 28. And that's it. Okay. Number 1, the discipline quotient varied inversely as the square of the number of unruly students. If the discipline quotient was 300 when the number of unruly students totaled 5, what was the discipline quotient when the number of unruly students totaled 10? Use the equal ratio method to solve. Okay. All right, so it says it varied inversely. So that means, what should we call all this stuff? Discipline quotient. Okay, I guess we'll say quotient 1 over quotient 2 equals unruly, I guess unruly. Okay, so unruly, because it's inversely, unruly 2 goes over unruly 1. And now you just plug in your numbers. So quotient 1 is 300. They're asking what was the discipline quotient when the number of unruly students. So this is what you're going to be solving for. So you're going to plug in what you have for quotient 1, what your unruly students 1 is, what your unruly students 2 is. You're going to cross multiply and solve for Q2. Number 2, the plane could fly 1,920 miles in 4 more hours than it took the racer to drive 320 miles. The speed of the plane was 3 times the speed of the racer. Find the times of both and the speeds of both. Okay. So it's giving us both the distances. So I'm guessing this is going to be our substituting for all 4 of those, the more complicated ones. So the plane and the racer. Okay, so the rate of the plane times the time of the plane, which equals distance, equals 1,920. Okay, then the rate of the racer times the time of the racer equals 320. Okay, the time of the plane in 4 more hours than it took the racer. So equals the time of the racer plus 4. And then the speed of the plane was 3 times the speed of the racer. So the rate of the plane equals 3 rate of the racer. Okay, now you've got TP and RP, so I would use this equation. And you're going to just plug in TR plus 4 times 3RR. Okay, and then that should give you an R of R, T of R that you can plug in the 320 into and then start solving all your stuff. Number 3, the initial pressure, temperature, and volume of a quantity of an ideal gas was 5 atmospheres, 540 kelvins, and 250 cubic meters. What would the temperature be if the pressure were increased to 50 atmospheres and the volume reduced to 200 cubic meters? Okay, so this is the one where you might already have these ratios memorized, but if you can just remember, temperature always goes on the bottom. Well, this one doesn't matter because you're going to be using all three. So sometimes we rearrange them because we're only looking for one thing, or we're rearranging them before so that, like, this is asking for what would the temperature be, so we'd get it to say T2 equals. You can do that. I would prefer to just plug things in, so however you want to solve that. So you're going to be putting in the pressure 1 was 5, temperature 1 was 540, volume 1 was 250. Okay, you're just plugging your stuff in and then cross multiplying and solving for T2. Number 4, after running for a while at 10 miles per hour, Mingo slowed to a walk at 5 miles per hour. If he traveled 60 miles in 8 hours, how far did he run and how far did he walk? All right, back to an old school distance problem. So we have the rate of running times the time of running plus the rate of walking times the time of walking equals, let's see, 60, because if he traveled 60 miles. Okay, now we can just plug in, after running for a while, his rate at running was 10 miles per hour. His rate of walking was 5 miles per hour. If he traveled 60 miles in 8 hours, how far did he run and how far did he walk? So you need to know you need another equation here. The time of running plus the time of walking equals 8. So this one's not as complicated as the last one. You're going to plug in your 10, you're going to plug in your 5, you're going to make this say T of W equals 8 minus T of R, or whatever. You can, and then you're going to plug into T of W, T of 8 minus T of R, okay, and solve for T of R. And then there should be 2 answers. They want to know how far did he run, so that's distance. So once you solve for T of R, you need the rate of running times the time of running, okay? And then how far did he walk? Then you need to plug your 2 numbers into here, and those will be your 2 answers. Number 5, the total weight of the sodium monohydrogen phosphate, and then they're showing you the number here, was 852 grams. What was the weight of the sodium in the amount of the compound? What percent by weight of the compound was sodium? Okay, this is a ratio problem. I think you know how to do these. You need to start by figuring out what was the sodium in 1 gram. So in this total thing, so we have 2 sodium grams. So that means our top number, 2 times 23 is 46. And then the total, I'm adding all this together. So 46 plus 1 hydrogen is 47 plus phosphate. You're just plugging this into your calculator. And then oxygen is 16, but there's 4 of them. So 16 times 4 plus your 78. So your total is 142. You need to understand how to find the total of these formulas that they give you, okay? And then pull out the 1 compound they're asking for. Now, it's just a simple ratio problem. They've given you the total at 852, and you need to solve for what the sodium weighs. Once you solve for X, you're answering the question, what was the weight of the sodium and the amount of the compound? Then you need to answer the question, what percent by weight of the compound was sodium? And you should know how to find a percentage. So the total was 852, whatever you get for that. You need 2 answers. All right, number 6 is what we did today. I don't know that I'm going to do both 6 and 7 because this this is not exactly a brand new concept. It's just adding one more layer to a concept we already know. Okay, so I got to start at the bottom and work my way up on solving for these. So my common denominator here is p. So I have 2p plus 2 over p. Okay, now I need to multiply by the reciprocal up here for this next fraction. So I'm going to kind of erase some of the things that I've done as we work this up. Okay, so now 2 plus, I'm going to take this m, forget the 2 so far, m times p, so mp over 2p plus 2. Okay, I've already dealt with this. So 2 plus mp, so 2 over 1, over 2p plus 2. So my common denominator now is 2p plus 2. So 2 times 2p, so I have 4p plus 4 plus mp over 2p plus 2. Okay, now I need to multiply, still got my m up here, all that by the reciprocal. So I'm going to erase this down here because this is going to be my bottom. So I have, you'll have to decide for yourself how you want to organize these. Or you just have them written all over your page. Because I have a whiteboard, I can do some erasing, but I don't have as much space to write. So m times 2p, so 2pm plus 2m. And then this would be your final answer. Okay, so that was number 6. Just checking that I had that correct. Okay, number 7, you're just going to do the same thing. Okay, so you need to find a common denominator for m and 3 over y, which obviously your common denominator is y, and you're just going to work your way up, just like I did on number 6. Okay, what do we have here? 6 and 7, number 10. All right, 5 minus I over 2 minus 3i. Okay, we can't have imaginary numbers in our denominator, so that's why we don't have square roots or i's. So this is just like the square root one, where we are going to multiply by the conjugate, because I times I is I squared, and I squared equals -1. But our numerator denominator rule says whatever we do to the bottom, we have to do to the top. Okay, so 5, this is where we're going to do our foiling. Okay, so first times first, 10, outer 15i plus inner minus 2i, so plus 13i, and then last times last, so -1 times 3, -3i squared, which turns into +3 because I squared is -1, and I'll deal with combining this here in a minute. First times first is 4, outer plus inner cancels out, -3 times 3 is -9i squared, so that becomes +9. So now I have 13 plus 13i over 13. Okay, I need to be able to, in order to simplify, checking if the I, okay, I can pull out of all of that. Okay, so I can't just write like I. That can't just be my answer, because I have to think 13 divided by 13 is 1. 13i divided by 13i is 1i. Or you don't have to write plus 1i, you can just write plus I. But you need to make sure that you're accounting for all your terms. You did get rid of the bottom. Okay, that was 10. All right, number 12. Square root of x plus 24 plus the square root of x equals 12. All right, I want x plus 24 by itself. So 12 minus the square root of x, square both sides. I have x plus 24, and now I'm going to FOIL. First times first, you're going to write it outer plus inner. which is not going to cancel out because they're both negative. So 12 times -1 is -12, and -1 times 12. So -12 plus -12, so minus 24 times the square root of x. And then square root of x times the square root of x, the square roots cancel out, and you're just left with x. So you need to FOIL that out and then solve for x and go back and make sure that that works. That was 12, 15. All right, these are your favorite. Right, -4r plus 7u in polar form. So I'm going to make my graph. -4r means it's the opposite of going to the right. So I'm going this way, and I have 4. And up by 7. Mine are never to scale, but you just need a basic picture. Okay, so first of all, I can use Pythagorean theorem to solve for this, okay? Then I can use tangent to figure out what this angle is. So second tangent is opposite over adjacent. So second tangent, 7 divided by 4. Once you have this and your angle, that's your answer in polar form. You're writing some number here at the point, at the angle, and then you're writing whatever you get for this angle with a degree sign. All right, 16. You should know how to do that. I'm not going to do that one with you. You need to find a common denominator, okay? You can flip-flop x minus 3, which will make this minus x over x minus 3. And that's obviously part of your x squared minus 9. So you just need to multiply x by x plus 3. Let's go ahead and solve for that. 18. I want you to try this one by yourself. It's just like the I problem we did. Can't have a square root in the denominator, so you're going to multiply by the conjugate. So you're going to multiply the bottom by 2 minus 2 times the square root of 5, and then whatever we do to the bottom, we do to the top. So the top will also be multiplied by 2 minus 2 times the square root of 5. So you're going to use FOIL for the top, and then for the bottom, you'll do first times first. Outer plus inner will cancel, and last times last, which will get rid of your square roots. So 18, 21. All right, I'll walk you through this one. I know these are tricky. Z over m squared equals p over m times x plus a plus, I'm going to write this as y over 1. Okay, I'm going to distribute first. So equals px over ma plus py over m. Okay, I need to find a common denominator to deal with this. I think that's what I want to do next. Just make sure I'm doing that right. Okay, yes. So actually I need a common denominator for all of this. So my common denominator is going to be am squared. Well, I'm just writing that to remember because then you don't have to, I'll write it over here. Am squared. So 2 is missing an a, so I have 2a equals px is missing an m, px m, and py is missing an a and an m, so py a m. All right, now at this point, it should be a little easier to deal with. You're finding p. Oh, and it's already laid out, so you just have to pull your p out. xm plus yam, divide, okay, and get your answer. All right, 24. I've kind of been skipping these, and then it showed up on the test, so I guess they really do want you to to know how to do these, or to be able to derive it yourself. I thought maybe you would just be able to go back and find the formula, but I think it's, at this point, I think it'll be good to know how they got the formula. Okay. Bx plus c equals 0. Okay, so the first thing I'm going to do is I can't have a coefficient when I'm completing the square. So I have to divide everything by a. So I have x squared plus bax plus c over a equals 0. Okay, now I'm going to move leave a little space here and move this over here. So I have negative c over a. Okay, now I'm thinking half, whenever I complete the square, I take half of my middle term and square it. Okay, so I have b over 2a, and I need to square that. So I'm going to do that over here so you can see it, which gives me b squared over 4a squared. Okay, I guess I could have just written that here, but I want to make sure you see where that came from. Okay, and whatever I add to one side, I have to add to the other side. Okay, now now I'm going to have x, I don't know if I'm cutting off here, x plus b over 2a squared equals, okay, now I got to take, well, I guess I could still write out this whole, okay, so I have flip-flop these around, b squared minus c, so I'm not starting with a negative, sorry, b squared, oh, I got to deal with common denominator. Okay, so common denominator is 4a squared, so b squared minus 4ac over 4a squared. Am I cutting off? Okay, I'm running out of room here on my board. Okay, so now to get rid of this square root, or the squared, I take the square root. Whatever I do to one side, I have to do to the other side. I'm just going to flip back in the book here to finish this. This is lesson 71 where they're showing it here. So we were on this step. Okay, took the square root of each side. Now we're going to take b minus 2a minus so that we have x equals, but whatever we do to one side, we do to the other. So x equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. We can combine all this since it's all over 2a. So my technical form, or my equation when I'm all finished, is negative b plus or minus the square root of b squared minus 4 times ac over 2a. Now, number 25 is now using that formula we just got. So you should be able to look at the formula you just got and figure out a equals b equals c equals. Okay, so you're going to have to get that equation to be in normal format. Okay, so everything's on one side, and then write in your a, b, and c, and then plug a, b, and c into the quadratic formula that you just did and solve. All right, 28, you should be able to do that on your own. Anything to the 0 is 1. You need to be careful of your negatives. If you have a negative exponent, you're going to be bringing that up to the top. When we have fractional exponents, the top number is what it's the exponent, and the bottom number is the root. And I think I told you with calculators like that 4, I'd rather take the square root of 4 is 2, and then 2 to the 5th power, then 4 to the 5th power, and then the square root. Although I can easily do square roots on calculators. I just find that to be a little bit easier. Okay, that's the end of lesson 82.